to take one metric variable, right? Then only we can find out mean, right? Right, very good. That is the first point. Then only we can find out the mean. Very good. First point, metric variable, right? Then compare means. What even the compare means? What even the compare means? Right, we are going to compare, right? Yes or no, madam?
Yes, sir. Yes, sir.
What do you mean by compare? We are going to have. When we can compare, madam?
When we have both value.
No, when we have two means, right?
Two means, yes, sir. Both.
Okay, when we have two means or three means, then only we can compare. Am I right?
Yes, sir. Yes, sir.
Yeah, very good. We need to have two means or three means, then only we can compare. So first we will take up two means, then we will go for other one, right? So now two means, right? Two means, right? Now we are going to take two all bivariate, right? So up to descriptive univariate over, descriptive over. Now from the cross tabulation bivariate. Bivariate means two variable, right? So now we are going to take two variable. One is a category variable, another is a metric variable, right? For a metric variable, we can find out mean, right? So in category variable, we will have two or three categories, right? Now let us assume that we have two categories in our variable. So two categories, the best example is gender, right? So we have one gender as one variable where I have two category, then I have one metric variable, right? What I can do is, right? See, for example, salary, right? So for example, okay, expenditure, right? One metric variable, right? Expenditure, or otherwise marks, anything, right? Or consumption, or the satisfaction. Now another variable is category variable, having two category, male and female. Then what we will do is, we will find out mean for male, okay, because it is another metric variable, right? I can find out mean for male and mean for female. Then I will compare. Right? By comparing, when I compare, what answer I will get? What answer I will get?
Average.
When we compare average.
No.
We are comparing the mean only, madam. Then when we compare, what is the result we will get?
Count better.
Yes?
Combine means, sir?
No, we are comparing, sir. Very simple thing I am asking. We are comparing. We are comparing two people. Then what we will get? We will get whether both people are same or both people are different. Right. So when the mean are same, they are also 10, here also 10, which means they are same. One people 10, another people 20, then we can say they are different. Can you understand or not, madam?
Sir.
Not understandable. Madam, your mark is 50, madam. Right? Another person mark is 80. I am comparing.
Sir.
What I can do? I am comparing yourself with another person. You are 50% mark. Another person 80% marks. Then I can find out that person is different from you.
Yes, sir.
That is what I am telling. When both people are 50, I can find out they are same.
Okay.
Yes or no?
Yes, sir. Yes, sir.
Okay. So, when we compare, we will get
Better difference.
that's all. Right, we will get, see, we are going to compare to find out whether they are different or not.
Okay.
Okay, so we are going to compare to find out whether they are different or not. Right. So now what is the null hypothesis here? What is the null hypothesis? Hello, madam. When we compare, we can find out whether there is a difference or not. What is null hypothesis?
No difference, sir. No difference. No difference.
Ah, yes, madam. I've already told you when you want to find out skewness, right? There is no skewness. When we find out there is a whether there is an association, we will tell there is no association. When we find out whether there is a difference, we will say there is no difference. Yes or no, madam?
Yes, sir.
That's all. That's all. Right. See, we are not applying our mind. That is why the words are all not coming. Okay, so now, see, for example, I have taken one example, right? I have taken one example. What is the example? What is the example? So I have taken one gender. I have taken one gender, right? So gender is having, right? Let us take one example, right? So now I have given some background.
Okay.
Okay, now see the data set, madam. What do you see, madam, data set? What do you see, madam, data set?
Gender in minutes.
Gender, right? We have one gender, right? Yes or no, madam?
Yes, sir.
What is that variable?
Categorical variable.
Madam,
Sir,
gender is a?
category variable. Sorry.
Hello, yes, madam. Madam, we have seen many times. So where is the problem, madam?
Sir, nominal, sir. I'm very sorry, sir. Nominal.
No, I do not want nominal. It is a category variable.
Yeah, category variable.
That's all. Okay. It is a category variable, right?
Yes, sir, category
Times we
variable.
have seen category variable, right? Very good.
Huh.
So very good. Because we are here, we have two category, female and male. Please see, madam. Please see.
Yes,
0
sir.
for female, 1 for male. Yes or no?
Okay, sir.
Okay, very good. Madam is little tense. That is why not giving answer. Free thinking should be there. It is very, very easy. Statistics is nothing. What we see, mathematics difficult. Statistics very nothing. All right. Okay. So now the another variable is average monthly minutes. Right.
Okay.
What is this variable?
Man. Average monthly minutes.
Madam, this is very, very important, madam. When we are not able to find out what is the type of variable, we cannot.
It is metric, sir. Metric.
It is metric, madam.
Already you told me, sir. One is category, one is metric.
No, that don't look at this one. See, now I have divided that twice, why you can tell. But when you are performing analysis in your data, all the variable will be there. Yes or no?
Yes, sir.
That way, please do not cheat yourself. Okay. So now, see, for example, here nothing is given. Where is the category here? Right? Can you see any category here?
No, sir.
None. Right. So here the scale is mentioned. Right. Then if you look at this one, let us look at the data. Right. So now look at the minutes. Look at the minutes. Can we find out frequency? Frequency find out பண்ணலாமா முடியாதா?
No, sir.
Why no? See, if you find out frequency, what you will get? 276 1, 189 1, 197 1, 256 1. Like that you will get? Yes or no?
Yes, sir.
Yes or no?
Yes, sir.
என்ன மேடம் அப்படி அரை மணி நேரம் கழிச்சு எஸ் சார்ன்றீங்க? What is the frequency, madam? Frequency is counting, yes or no, madam?
Yes, sir.
So, how many ones are there? How many twos are there? That is why first day itself I have told you frequency. Right? Okay, so we cannot find out the minutes frequency. So, this is a metric variable, right? Okay, very good. So, now I have one category variable, one metric variable, right? Very good.
Okay.
Right. So minutes. See, what is the data is? we have asked okay, people how much time they are talking in the cell phone. This is the old data. How many time, how much minutes they are talking in the cell phone. Right. We have asked from male and we have asked from female. Right. So how many times they are talking, how many minutes they are talking per month. That is the very old data when it was introduced in the beginning. Right. So now what I can find out is right. So 1 and 0. So 1 is what is 1? So 1 is male, 2 is female, right? So now I can find 1 is male, 0 is female. I can find out average of male and average of female. Average of men, and this is the most simplest technique which I am going to tell now. We cannot have any other technique simpler than this statistics, right? So now we are going to compare, right? What we are going to do is we are going to find out the average monthly minutes of male, average monthly minutes of female. We are going to compare to find out whether they are different, right? So now we are going for analyze, compare means. So when you have two category, we are having one category variable, having two category. When we have one variable, which is a category variable, having two category, another is a metric variable, right? In that case, we have to go for independent sample t-test. What t-test?
Independent sample t-test.
Very good. When we have one category variable, having two category and another metric variable. Yes. Tell madam again.
When we are having one category with one category variable with two category.
And
another metric variable.
Correct. So what we will be doing is we will find out
Comparing
for every category. We will compare and to find out whether there is a difference. So null hypothesis is what is null hypothesis?
null hypothesis is
Difference, sir.
Huh?
There is no difference between the. Correct, no, sir?
Now we are comparing we are comparing the average monthly minutes of male and the average monthly minutes of female. Yes or no?
yes sir.
Now you tell.
No differences sir.
Tell. There is no.
There is no difference between the average monthly minutes of female and average monthly minutes.
That's all.
There is another one.
Okay, so there is no difference. You have to write very carefully. All the people are writing wrong. Alright, we are comparing two groups. So we are trying to find out whether there is a difference between the groups. Right. So we are trying to find out, right, whether there is a difference between male and female. So there is no, please madam write it down, you should not make mistake. There is no difference between male and female with respect to number of minutes they are talking in the cell phone.
Yes sir.
Clear?
Yes sir.
Clear, madam. Right. Simple, madam. Very simple. But many people, what mistake they are committing is, we are taking two variables. No, they will say there is no difference between gender and monthly minutes. It is absolutely wrong because gender and monthly minutes they are different only. Yes or no? So we are comparing means, right? That is why, see, they have made it very easy for us. Analyze, compare means. The word itself very clear. Compare means, right? Okay. So independent sample t-test, right? Here you have to be very careful. You have to put here. You have to be very very careful. You have to put metric variable is the test variable, right? Metric variable. Compare means that mean variable. That metric variable is very very important. Right, metric variable is very very important, right? So gender is categorical variable, put it here. Gender is a grouping variable, group, right? The defined group is not there, right? Madam, you have to tell me what I have to do. Here it is okay, it's not coming. Then what to do?
It's a range 1 to 5.
Define groups. எங்கே போகக்கூடாது. அட்மிஷன்ல வேற யாராவது போட சொல்லுங்க. Don't yourself get involved in any other work. Okay. What I have to do now? Okay, it's not coming, madam. What I have to do?
Define groups, sir.
Define groups.
That
Now
is-
here what I have to do?
That is, we are given male, female, no, sir.
Give.
Group one male.
Shall I type male?
Yes, sir.
One.
Shall I type one? Right. Let me put one. Group two.
0.
Female 2.
0.
Right. 0 you can put. Let me put 0 here and 1 here. Right. So you cannot type male and female. Why we cannot type? Here our data is 1 and 2 only, right? Yes or no?
Yes, sir.
So continue, right? We have put a 0, madam, here because for female we have given 0. Yes or no, madam?
Yes, sir.
That is why I showed you 0 is female, 0 is female. Whatever data you have to put, right? Continue, right? Let me say, okay. இப்ப வந்தாச்சு. இப்ப என்னப்பா what we have to see? What we have to see?
Yes, that's 0.2.
What we have to see? Significant value. Yes or no, madam?
Yes, sir.
Significant value.
What is the significant value? Give that significant value.
0.05.
Where it is 0.05.
No, sir.
Better rate, ma'am.
0.09.
Yes. It is more than or less than.
What is the significant value? Tell madam.
Less than
That
0.0.
Sir, voice
No.
break.
What is the significant value here?
Here 0.009, sir.
You tell that, madam. Then we'll go. See, here the significant value is 0.009.
Okay.
See, normally I will tell many so right, madam.
Sir,
Madam. Okay. That there is a bachelor boy. Right.
sir, voice break.
So there is a bachelor boy, madam. Right, madam.
Voice breaking, sir.
Okay.
Not clear.
Right, madam. The it is going for alliance marriage, right? Alliance, seeing a girl for alliance, right? Right.
So there is one instruction, sir.
Single scheme.
Sir, actually the
What
climate
is
condition
it?
is not good. Therefore, participant, please adjust it. There is some disturbance from the climate. Okay, please adjust it. There is no any option from our side. Okay, thank you. Sir, please continue.
Sir, what is that?
Sir, network
What,
issues.
sir?
Hello.
Network issue.
Too rainy, sir. In Karnataka, it is too rainy. So therefore, voice is breaking.
Due to
Yes, sir.
climate condition, there is network issues, sir.
From I'm also sitting in the home, sir. Right. I'm connected with mobile phone, sir. So I
Yes, sir. Yes, sir. I am requesting the participants, sir. Try to adjust it. That's all.
See, if there is a no, sir, if there is a continuous problem, right, sir, we can take up the tomorrow also, sir. That is not an issue, right? Because if they are not understanding, there is no point in. Okay, so
Doing. Somehow, no problem. You can continue, sir. From the same is no problem. You can continue.
Okay, so now that is why I'm always talking to madam, right, to find out whether I have any issues. Okay, okay. So now I cannot open the door also because I have put AC. So okay, so doors are all closed. Right, very good. So there, see, let me tell a story. The story is, see, one boy is going to see alliance. Right, madam?
Okay, sir.
His uncle is taking. Alright. So now before going to the girl's house, the uncle is telling to the boy, hey Mapla, we are going there to see a girl, ra. Very good, mama, no issue, no issue. Hey, in that house, there are two girls. There are
Two girls.
two girls. One is elder one, another is a younger one.
Okay.
Right? But we are going there to see the elder one. Right? We are going to see the elder one, right?
Okay.
So the uncle has given an instruction, right? Okay. The boy is sitting. The boy is sitting. Right, very good, right? So when he is sitting, one girl has crossed like minnal. Hmm? Who is that girl? Who is that girl, madam?
Younger one.
Younger one, right? Younger one has crossed. Now, what the boy should do? He should not see that girl. Am I right?
Hmm.
Yes or no, madam?
Yes, sir.
Right. The girl might be good. The girl might be good, right? So now he has seen that girl. The girl is very good. Now he is asking that uncle, uncle, okay, you fix this girl, right? You fix this girl. Now, see, this boy can tell, but whether uncle can tell it to that to their family members, if they are telling, they will beat with broomstick. Yes or no?
Yes, sir.
Yes or no, madam?
Yes, sir.
Okay, so the younger one might cross. You should not see. You should close your eyes.
No.
Yes or no, madam?
Yes, sir.
Okay. Why I am telling this story? Because what test we have performed is independent sample t-test. Tell madam.
Independent sample t-test.
Right. So simply we have performed the t-test. What test we have performed?
T-test.
T-test. So we went there to see the elder one. Then you have to see only elder one.
Okay.
We have performed t-test. So you have to see only t. Right. So now here is a t. Here is a significant value for t. But this is the significant value for F. The younger sister has crossed. You should not see. Yes or no, madam?
Okay, sir.
So you should not see this one, right? Here you should see this one.
Okay.
Yes or no?
Okay,
Because
sir.
what test we have performed?
T-test.
Now please understand, madam. See, when we perform test, many tests simultaneously it will give, many result also it will give, right? So first we should look at what we want. Then we can look at the other things, right? Okay. Now we have to see the t-test, right? So which means here we have to look at here 0.592, 0.581. But the problem is here we have two significant value. What is the problem?
Two significant value.
So now the boy is having another problem. Now the uncle is telling, hey, we are going there to see the elder one, ra. But the problem is they are twins, ra.
Twins.
They are twins. Okay, so now the again he is telling that though they are twins, ra, among the twins one is already married.
Oh.
One is already married, right? So we are going to see the remaining one, right? Very good. So when it is married, we have to see whether that girl is married. When she is married, we have to reject. We should not see that girl. Am I right?
Yes, sir.
We have to see the other one, right? We should not. When that girl is married, we
There
should
is no
not see that
freedom to-
girl. You should see the another girl. Yes or no?
No freedom to select, sir.
Okay, so that is what you have to see now. Now the story is, now this F value, right? This significant value, right? How to identify whether the girl is married? Okay, when the girl is wearing metti, she is married. Yes or no?
Sir.
Okay, so now this is the metti for you. This significant value is the metti for you. Right. So now I will tell the solution. Right. Now, first you have to look at this F significant value.
Okay.
We have to look at this F significant value. If F significant value is less than 0.05, then we have to reject the equal variance axiom. If it is less than 0.05, okay, if it is normally, if it is less than 0.05, we will reject. Yes or no, madam?
Yes, sir. Yes, sir.
When it is less than 0.05, we have to reject the equal variance axiom. Then that girl is married, reject. Then we look at this one. We have to look at the equal variance, not assume. So which means here we have to look at this 0.581, right? So let me tell you again. So first we have to look at the F significant value. If this F significant value is less than 0.05, reject that equal variance axiom, then see the equal variance, not assume. Right. Now suppose if it is greater than 0.05, if it is greater than 0.05, okay, so that equal variance assumed is accepted. That girl itself not married girl. Okay, so you see that girl. When it is greater than 0.05, see this one. When it is less than 0.05, see this one. Simple. Right? Yes or no, madam?
Yes, sir.
Now tell again, madam, tell. When F significant value
when you see F significant value, if it is less than 0.05, we have to reject equal variance assumed. If it is more than 0.05, we should accept it.
We have to see that value. Simple, madam. Okay, so reject and all you do. Okay, you write it down. That is fine. If it is less than 0.05, see second one. If it is greater than 0.05, see the first one. Simple. Over?
Yes, sir.
Very good. So now here the value is 0.009. Is it less than 0.05 or greater than 0.05? Madam?
Sir,
less than 0.05.
Sir?
It is
Less than
0.009.
0.05.
It is less than 0.05 or greater?
Less, sir.
Seriously? Madam, 9, madam?
Yes.
One
No.
is there, sir.
No,
Madam,
sir, it is
9.
0.
It is
0.009, sir.
It is 00, 0.00.
Yes, sir.
Right. So since it is less than 0.05, we have to look at the 0.581. Right. Very good. Now madam should tell the significant value is 0.581, which means we have to less than 0.05. Yes or no?
Yes, sir.
0.581 is greater than 0.05. Yes or no? Hello, 0.581 is
Yes,
greater
sir.
Yes, sir. Greater than
0.05. Yes or no?
yes, sir.
0.05. Then we have to
No.
Should
Accept.
accept.
We have to accept the null hypothesis, right?
Yes, sir.
What is the null hypothesis?
No skewness.
No difference.
No difference
Between the
between male and female, right? Okay,
Female.
which means what is the meaning of there is no difference? So boys are also talking, girls are also talking, all are talking. There is no difference. We cannot tell boys are talking more or girls are talking more. We cannot tell. There is no difference. Am I right?
Yes, sir.
Mean values are same. Am I right?
Yes, sir.
Very good. Right. So now matter is not over. Now, okay. So now, Madam, please be ready. I'm going to perform another one. Right. So now, okay. So now, see, I've taken a lot of time. See, within I should have taken only 20 minutes for this one. We have taken more time. Okay. So, okay. Madam, ready?
Yes, sir.
Now, can you see some data set or not visible?
Not visible, sir.
Not-
Employee detail is not visible.
Not visible. How do you say not employee data is not visible?
That file is visible, sir. The two.
Sir, you are at a D drive, sir. Still it's not open.
I can see the
Ah.
detail.
Now is it visible, madam? See, sorry.
Average monthly minutes.
Now visible, madam?
Yes, sir. Employee
Now-
details
Sir,
now visible,
visible,
sir.
Okay. Now you have to tell me. It contains two variables, right?
Yes. One is
Now, what
Sir,
are the
no, sir,
variables?
no.
name?
Yes, sir.
Gender is category variable.
Very
Then
good.
We have two category. One is male, another one is female.
Very good.
Salary is metric variable.
Very good, madam.
So we
Super,
have-
madam. Super, madam. Super, right? So now,
When we have one category, one metric, we should go for independent sample t-test. Let
Very
us
good.
compare the means. Go to analysis. Go to analyze.
Okay, madam. See, okay, wait, madam. See here, let me tell again, madam. Okay,
Yes,
so
sir.
now variable view,
What's the one? What is the
salary, here none, scale, metric variable. Then gender, I have two category. One is male, that is one. Two is female, right? Very good. So now if you look at the data, okay, salary 57,000, 40,000, 21,000, which mean I cannot find out frequency because each are different variable. Now here I can find out frequency, how many ones are there, how many twos are there, I can count. So I can find out frequency. So I got one variable gender, which is the frequency based variable, otherwise called category variable. Another is a salary, which is a metric variable. So now, okay, so now when I have two variable, one category, one metric, in the category variable, I have only two category, I have only T category, then I can perform independent sample t-test, right? So how to perform independent sample t-test? Analyze, compare mean,
independent
sample t-test. Very good, right? What variable I have to put it on the top?
First, that is metric variable.
Good, madam. What is the metric variable?
Salary.
Salary, good. Gender, grouping variable, right?
Yes.
Then define groups.
1, 2, 1, 2.
1, 2. All right, 1 and 2. Here, female 1 and 2. Right. So now 1 and 2.
Continue.
Very good. Continue.
Okay.
Okay. Very good. Now, okay. So now, result is ready. Yes.
Result is ready. Now, it's just when you. Oh, 0.000.
Which one we have to see? First, we have to look at the F significant value.
Significant value. If
Which
it is less than 0.05.
No, wait. It is 0.000, which is less than 0.05. Yeah, next. If it is less than 0.05, we have to reject that.
Yes, sir.
Equal variance assumed. Then we have to see the equal variance.
Equal variance not assumed.
Right. Now, what is the significant value for equal variance not assumed?
0.000.
0. Right. Tell me now. What is the null hypothesis?
Rejected.
No. What is the null hypothesis?
0.000.
Now, what is the null hypothesis, sir? Statement. There is
No difference.
no difference. Madam, tell. There is no difference
No difference.
between
Male and female.
Between salary
male
of
and female.
Towards salary.
With respect to salary. Right? Very good.
Ah, sir.
There is no difference between male and female with respect to salary. Right? That is the null hypothesis. Now the significant value is 0.000, right? Which is less than 0.05.
Yes,
If
sir.
it is less than 0.05, we have to
reject.
Yes.
we have to
Reject, sir.
eh?
Reject.
we have to reject the null hypothesis. Yes or no, madam?
Accept it.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. So null hypothesis rejected, right? So now alternate hypothesis accepted. What is alternate hypothesis? There is a difference between male and female
Female.
with respect
With
to
respect to-
salary. Yes or no?
Yes, sir.
What do you
Yes.
mean there is a difference? So which means some people are getting more salary, some people are getting
Some
less
people.
salary. Yes or no, madam?
Yes, sir.
Yes, sir.
Yes,
Yeah.
sir.
Now, see, now you should not stop. Now we need to know. See, for example, I'm comparing one person with another person. I could find there is a difference. Then I should see who is having more, who is having less. Yes or no, madam?
Yes, sir.
Okay. So I need to find out who is having more and who is having less. Yes or no?
Yes, sir.
Yeah. Now, how to find out? Now look at the one more table here. All right. Here, see the table. Right? See the table. So now, what you see in this table? Now we say that there is a difference. Yes or no, madam? No, madam. We say that there is a difference. Yes or no?
Yes, sir.
Now see the values, madam. Male, how much?
258.
That is number, madam.
Number. Mean is.
Okay, we are comparing means, madam, right?
Yes, sir.
So, madam.
40. Yes, sir.
You compare. You see the mean value. Don't look at the number of male, number of female, right? Yes or no, madam?
Yes, sir.
Mean. We are comparing the mean. See the mean value for male.
Male is high, sir. 41,441
Female.
less. That is 26,031.
Now can you see the difference?
Yes, sir.
Now how much difference? How much difference? So that is what it is written here. So for 15,000 mean difference. Can you see the mean difference?
Yes, sir.
15,409.
Mean difference.
Yes. Yes. Yes or no?
Yes, sir.
Very good. Now, okay, now, right. That's all, matter over. That's all, matter over.
Okay, sir.
Okay, that is what you have to see, right? Okay, so now we will try to understand something more. What is that more? See, for checking whether there is a skewness or not, what I have done, skewness divided by standard error I have put. Do you remember, madam? That is what we said that find out t value. Yes or no, madam?
Yes, sir.
Skewness divided by standard error, right? Right. Yes or no? For curtosis divided by standard error.
Yes, sir.
That is the t value we have told. Yes or no? That
Yes.
is the, I have told you it is a common, universal, right? Estimate divided by standard error, right? Estimate, there skewness is our estimate, in kurtosis is our estimate. Now here our estimate is the difference, right? We are trying to find out only difference. Yes or no, madam?
Yes, sir.
The difference, we are trying to find out difference. What is the difference? 15,409. Am I right?
Yes, sir.
That is the difference. We have standard error. Here we have standard error, right?
Yes, sir.
This is the mean difference divided by standard error 1400, right? So 15,000 divided by 1500, that is mean difference divided by standard error is the t value.
Yes.
Yes, right. So that see that when you know one concept, that is applicable to everywhere. Everywhere we can see. Everywhere we can see.
Yes, sir.
Okay, in regression, everywhere it will come. What we are estimating, right? What we are trying to find out, that divided by standard error is the t value, right? Clear now? So
Yes,
this
sir.
mean difference divided by standard error is this one. So here it is 15,000 divided by 1,300. So it is 11. Very good. Now, right. See, now, right. I have told you how to find out interpretation based on significant value. When the significant value is less than 0.05, reject the null hypothesis, right? Yes or no? Yes,
Yes,
or no,
sir.
madam?
Yes,
Yeah.
sir.
Now, I'm not going to look at the significant value.
Wait.
I'm not going to look at the significant value. Now I know what is t value, right? T value is mean difference divided by standard error, right? So
Yes, sir.
now t value, how the t value should be, how to interpret. Already we have discussed when the t value is when the t value is, we have already seen. When the t value is, see, when the significant value is less than 0.05, reject the null hypothesis. When the t value is
1.96.
when the t value is
1.96.
no, you have to tell less than or greater than.
More than 1.
Yes. When the t value is more than 1.96, reject the null hypothesis. That is all the matter. That's all the matter. Now look at this. Here also I have written. So look at the t value, right? Significant value 0.05, 1.96. 0.05, 1.96, right? So when this is less, when it is coming down, 10%, 5%, 1%, coming down. Here 1.64, 1.96, 2.58. Okay, here also you can remember 468, 1.64 to 1.96, 2.58. All right, you need not get confused, right? So when the t value is more than 1.98, reject the null hypothesis, right? So now let us look at here, right? See, based on significant value, right? So we have seen this significant value because this is less than 0.05. We have seen this significant value. This is less than 0.05. We have rejected the null hypothesis. Now look at the t value. Okay, 11.68, which is definitely more than 1.96, which means reject the null hypothesis. Same result. Yes?
Yes, sir.
That's all matter. That's all matter.
Nice, sir.
Right. So now, now, okay. I can tell one more thing, but if you tell what is the logic now, okay. So I may not tell now, okay, but now, okay. Now, okay, we can decide based on significant value, or we can decide based on t value, or otherwise we can look at one more, right? When the lower and upper, when the lower and upper here, when the lower and upper confidence level, when both are positive, all right, here we are seeing this one, second one, right? Here, this is also positive, this is also positive, right? This is 12,000, this is 18,000. Am I right?
Yes, sir.
This is 12,000, this is 18,000.
18,000.
Am I right? Yeah.
Yes,
So now, which means reject the null hypothesis, right? So when the both values are positive or when both values are negative, reject the null hypothesis, right?
Oh.
So now here both are positive, so reject the null hypothesis, right? Okay. So now when I have seen yesterday, when I explored the lower confidence, upper confidence also we have seen. I have not explained, but we have seen, right? How this lower confidence and the upper limit is calculated. Right. So now estimate. What is our estimate? This mean difference. That is our estimate. Everywhere estimate. Right. Plus 1.96. 1 point. This value is and all you know. 1.96 into standard error is the upper limit. Right. So now, see, it is 15,000, right? 15,000, right? So this is 1,400. Let us put it as approximately 1,500. 1.96. Let us put it as approximately 2. 2 into 1,500. It is 3,000. 15,000 plus 3,000, 18,000. Madam?
Yes, sir.
Okay. The mean difference, that is estimate, plus 1.96 into standard error is the upper limit. Estimate, that is mean difference, minus 1.96 into standard error is the lower limit. Minus is lower, plus is upper. Right? Hello?
Yes, sir. Sir, voice.
Okay.
Your voice is not clear, sir.
You
It's breaking.
voice is not clear.
No, it is not clear, sir.
Now, yeah, now it says my internet connection is unstable, right? ஆகாஷ் ரியல்மி ஒண்ணுதான் இருக்கு, ஒன்னதான் போடுறா, என்னதான் போட்டு விட்டுட்டு அம்பாடுல இருக்கான் பாரு, ஒன்னதை போடுறா டக்குன்னு. ரமா இது எப்போதும் இருக்கும், பட் கனெக்ட் பண்ண முடியாது. சரி, அப்ப அன்பிளாக் பண்ணும். ரொம்ப ஃபாஸ்டா வருமா? ஜியோ தானே ஒன்னதான். Vema.
Sir?
No, wait, madam. I will connect with some other connection, madam. Hello?
Ah, sir, no problem.
ஒன்னதுன்னா நோ இன்டர்நெட்ல காட்டுது.
Nandini ma'am.
Yes, ma'am. Sir, disconnect ಆಗಿದ್ದಾರೆ ಮ್ಯಾಮ್. ಅವ್ರ ನೆಟ್ವರ್ಕ್ ಇಶ್ಯೂ ಇದೆ. ಜಾಯಿನ್ ಆಗ್ತಾರೆ ಬೇರೆ ಇಂಟರ್ನೆಟ್ ಕನೆಕ್ಷನ್ ಇಂದ.
ಇದೆ.
CSK sir.
ಸರ್ ಜಾಯಿನ್ ಆದ್ರು ಇವರು ಕಾಸಿಲಿಂಗಂ ಸರ್.
Okay, ma'am.
ಕಂಚ ಮ್ಯಾಮ್ ಅವ್ರನ್ನ ತಿರ್ಗಾ ಕೋವರ್ಸ್ ಮಾಡಿ.
ಒಂದ್ ನಿಮಿಷ.
ಕಂಚನ್ ಮ್ಯಾಮ್
ಒಂದ್ ನಿಮಿಷ ಸರ್
Forward
ಮಾಡ್ತಾ
ಮಾಡಿ
ಇದ್ದೀನಿ.
ಅವ್ರನ್ನ.
ಹಾ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಆಯ್ತು ಸರ್.
So now we will see. Okay. Is it okay? Hello, madam.
It's not visible, sir. It still started screen sharing.
Not screen is not visible. Huh?
Not visible, sir. Now it is visible.
Visible.
Average monthly minute SPSS.
Right. Visible. Huh? Very good. Okay. So now is it okay or again, madam?
Sir, you should explain from upper and lower, sir.
Upper and lower I have to explain. Okay.
That
So now I will
not
explain.
visible, sir. That
Visible not visible?
sir, SPSS screen is visible, sir.
Come on.
Analyze.
Internet links, come on. So now, okay, the salary is okay. Salary is
Sir, voice is not clear.
voice is not clear. So, madam, is it okay?
Yes, sir. Yes, sir. Yes, sir. Now it is okay.
Okay. So now independent sample t-test okay, or shall I tell one more result? Hello, I will okay. So now I will perform whether let me have one more. Let me do one more. Right. So, okay. So now I have two variable, three variable, right? Okay, madam, I have three variable. So one is a sex, which is a gender, right? Okay, so
Another
it is having yeah. Now is it visible, madam, screen?
No, sir.
When you
Delete
open
rated files.
okay.
And now it is visible, sir. Average monthly.
Yeah, now okay. So now okay. So now I have this is okay. So gender is a category variable, right? Gender is a category variable, and okay. So see here, okay, it is mentioned as scale. So don't get confused, right? Let me change it. So this is a scale variable, right? Okay. So now I will perform how to perform, right? Okay, madam.
Sir,
Analyze.
sir, what are the three variables we are using here, sir?
Let us see, madam. Let us see.
Oh,
right.
okay, sir.
Two metric variable, one category variable, madam. Right.
Okay, sir.
So first is a category variable. Another is a motive, saving motives. Right. Saving motives. One is a self-support motive. another is a family oriented motive. So the idea is why people save, whether to support ourselves for the future, right? Otherwise, we have to leave something to the family, something to the children. That is for family oriented. So for the family, I have to save. That is the family oriented motive. That motive, interest. So another is self support. Yes or no, madam?
Yes, sir.
Both are metric variable, right?
Oh,
So you can none is available. Can you see none?
Yes, sir. Yes, sir. I can.
Which means metric variable, right? Now,
Okay, sir.
analyze, compare means, madam.
Yes, sir. I'm here.
Compare
Compare.
means
Again, independent sample t-test or new one, sir?
independent.
Okay, sir. Okay. Independent.
Independent sample t-test.
Okay. Now, metric variable. Two metric variables are there. No, sir?
I can put two also. That is why, right? I can put two also. No
Okay,
problem, right? Here, one category variable, right? Here, define groups,
Yeah.
right? Define groups, right? What I have to put?
That is a 0. I
No,
don't know.
1 and 2.
Values.
1 and 2. We will see. Okay, so we will see. If we have doubt, we can see, right? So male 1, male 2. Yes or no?
Yes, sir. Yes, sir. Yes, sir.
Now which means I have to put
1.
1 and 2. 1 and 2.
2.
All right, very
Yes,
good.
sir.
Continue. Say okay. So now how to proceed? Yeah.
Okay.
How to proceed? So let us go now. Since we have two metric variable, 2 times independent sample t-test is performed, right?
Okay.
So first we will take up the self-support motive. First we will take up the self-support motive.
Support
Yeah.
motive.
Now tell.
What is this? Significant. Significant is
Which one we have to see?
P.
No, first we have to see what? We have to see the F significant value.
When we see the F significant value, when it is less than 0.05 or more than 0.05, we need to check.
ஏதாவது ஒண்ணு சொல்லுங்க. Don't tell both. When it is less than 0.05, what here it is more than 0.05. Yes, or no?
More. Yes, sir.
And then what we have to do?
We should accept the same, sir. That is, equal variance assumed.
Okay, which means I have to see this value. Am I right?
Yes, sir. Yes, sir.
0.002. Yes or no?
Yes, sir.
Okay. So now what is this 0.02?
0.002. That is
less than 0.05.
Less than 0.05.
Yes, sir. When it is less than
every time less than 0.05 reject the null hypothesis. Less than 0.05 reject the hypothesis. Less than 0.05 reject
sir, reject, sir.
Less than 0.05 mindல இருந்து ரிசர்ச் பண்ணா என்ன அர்த்தம்?
Yes, sir. Reject, sir.
ஓகே. சோ திரும்ப அது ஒரு சிம்பிள் விஷயம். திரும்ப போய் மைண்டுக்கு போக வேண்டிய அவசியமே இல்லை. ஓகே. ஒரு சின்ன விஷயம். less than 0.05 means reject the null hypothesis.
Reject, sir.
இது உலகத்துக்கே whatever the test we perform same thing. Why we should not remember this one? Right, very good. So now it is less than 0.05. Reject the null hypothesis. What is the null hypothesis? No difference.
No difference between male.
Okay, no difference is rejected. Which means there is a hello
sir.
Tell madam. நீங்க சொல்ற வரைக்கும் நான் எதுவும் பேச மாட்டேன் மேடம். நீங்க சொல்லலன்னா let me stop here. Okay, here the significant value is 0.002. What you are trying to tell?
When it is 0.002, it is less than 0.05. We have to reject it.
Okay, reject the null hypothesis. Don't reject it.
Reject the null hypothesis.
What is the null hypothesis?
That is male and female both. And there is no difference, sir.
Okay, no difference is rejected.
Huh.
Which means?
There is a difference.
Hello, madam, சொல்லுங்க மேடம் சொல்லன்னா நான் இன்னைக்கு போறதுல பட்டேன் 2 மணி நேரம் ஆயிட்டு போகுது. No problem.
Sir, you please consider Shivkumar sir answer also.
No. See, when I am not able to teach you, I am not a teacher. See, you are a teacher. When I am not able to teach to a teacher, then how can I teach to the students? See, I cannot expect the student to come with the knowledge. I cannot expect. How can I expect student to come with the knowledge? If they have knowledge, why they are coming for listening? Yeah, now tell madam.
There is no difference between.
No. First, null hypothesis. How to fix the null hypothesis? We are trying to find out whether male and female, whether they are different in self-support motive and family-oriented motive, right? So, which means null hypothesis is there is no difference. Yes or no?
Yes, sir.
Yes, sir. What is alternate hypothesis? அங்கேதான் உங்களுக்கு குழப்பம் மேடம். முத நாள்ல இருந்து உங்களுக்கு குழப்பம் என்னன்னா alternative hypothesis தான் there is a confusion. Madam, when null hypothesis is no, this is yes, madam. There is no confusion. Hello?
Yes, sir.
ஒரு பொண்ணை பிடிக்கலன்னா அடுத்தது பிடிச்சிருக்கு, அடுத்ததுக்கு போகணும்.
Yes, sir. Yes, sir. When null hypothesis is rejected, alternative hypothesis is accepted.
What is alternate hypothesis?
There is a difference.
அப்புறம் என்ன குழப்பம் உங்களுக்கு? There is a difference. Now tell here the significant value is 0.002.
When it is 0.002, it is less than. It is less than 0.05. We should reject the null hypothesis, accept the alternative hypothesis.
What is the alternate hypothesis?
There is
a
Difference.
difference, sir. There is difference, sir.
And there is a difference on what? Difference
between gender and self-support. That is male and female with respect to self-support.
Madam, நடுவுல ஒரு கெட்ட வார்த்தை பேசுனீங்க. There is a difference between this one and that one. That is a bad word. Okay. There is a difference between male and female. There is a difference between male and female with respect to self-support. Right. See here. Hello. See here. Now let us look at the mean value. Right. So a male 2.5, female 2.3, which means male they are having higher value. Yes or no?
Yes, sir.
Female they are having lower value, which means the male they save mainly to support. Okay, namanda pillalena we should not depend upon their children. We should save, right, to safeguard ourselves. But the female they will give more. Okay, so self support no. So such a thing they will have. They think that wife is there, husband is there. Okay, my children are there. They will take care. The female will think like that. But men, they think no. I should say self-support, right? Okay. So now let us look at ipo adutha solunga madam. Okay, family oriented. Idha solunga. Now proceed quickly, madam.
Yes, sir. Family oriented, no, sir.
Family oriented. Yeah. Now what we have to do?
When it is significant.
What we have to see first?
Frequency. Significant.
Frequency. Yeah.
That's significant.
F significant.
F significant.
Here F.
Okay, sorry. F significant.
F significant. What is this value? 0.944.
It's more than 0.05.
Okay. which
And it
means
is-
we have to see the equal variance assumed,
Yes, sir.
right? So which means we have to see 0.668. இப்போ சொல்லுங்க 0.668.
0.668 is more than 0.05.
Hmm.
So when it is more than 0.05, we should accept the null hypothesis.
What is null hypothesis?
There is no difference.
There is no difference between male and female. Yes or no?
Yes.
Now see, male 3.3, female is also 3.3. There is no difference. Yes or no?
Yes, sir.
That's all, matter over. Right. Okay. So now, wow, what is the t value? T value is
T value is
difference.
difference
Mean
between
difference divided by standard error.
Standard
error
error.
difference.
Okay. Now look
So
at the t value.
3.1.
Okay. Now the t value is 3.1. Now
3.1.
tell the result. When the t value is more
More
than
More
than
than 1.96.
96.
we reject the null
Null
hypothesis.
hypothesis.
The
That is why
hypothesis
see here.
accept the alternative.
Okay. So now see here 0.02. By significant also reject the null hypothesis. Both will be same. We cannot give different result, right?
Okay, okay.
Okay. Here, see here. Less
Here
than
also-
1.96. Yes or no?
Yes, sir. Less than.
Here greater than, both are same result, right? So it should be more same result only. You cannot get.
Yes, sir.
See, in fact, see, we should look at only t value. This significant value is the derivation of t value, right?
Okay.
The t value is the calculated value. We are looking the t value in the table. Okay. So this is what we have seen in the table. So based on this only, this value will come. Right. Very good. So with this, I think we will stop. All right. Okay. So now we have taken for one single test, we have taken too much time. So now we will go for okay. So we'll go for next one. Okay. Normally I will complete few more things. Okay. So now we have taken two variables. One is category variable with the two category. Am I right, madam?
Yes, sir. Yes, sir.
Another is the metric variable, right? Now, what is the
Sir,
next?
Sir,
Yes, madam.
Which, sir, output screen is visible, sir.
Now I will come. I have not touched anything.
Correct.
I have not
Okay.
touched.
Okay, sir.
I am
Okay.
asking question, madam. Now,
Yes, sir.
you please think it over. Everything is thinking process, right? Number, first one. We have taken one category variable, one metric variable, right? But in the category variable, we have taken only two category. Yes or no?
Yes, sir.
Okay. Now that is C. Now,
Yes, sir.
what is the next alternate? Next possibility? What is the next possibility?
That is category over. In that way, no, sir.
That is we have seen I square.
Yes, sir. Another
Now-
metric.
No.
No, madam. No. Still not over, madam.
Okay, sir.
We have seen one category variable, one metric variable, right?
Okay.
In category variable, we have taken only two category. Yes or no?
Yes, sir. Yes, sir. Yes, sir.
Now, you tell what is the different possibility?
Categories. So that is male, female, between those two.
Madam, very simple, madam. See, we have taken only two category. Yes or no?
We should check with
There is a possibility for three category and four category. Yes or no?
Yes, sir. That is more than two.
More than two. Is it possible? For example, we had some income, five
Possible.
categories we had, right?
Yes.
Yes or
Answer.
no, madam?
Yes, sir.
Yes.
Yes, sir.
All right. So we will be having category variable with the five categories, six categories, three, anything you might have. Yes or no?
Possibilities are there, sir. Yes, sir.
So when you have a one category variable with
Mhm.
more than two category, that is the ANOVA. That is where we have to go for. You know, madam?
ANOVA.
ANOVA. Very good. So now let me go to ANOVA. ANOVA will take 1 hour. Okay, we should have taken independent sample test only half an hour. So madam has taken lot of time. Okay, now let us see. ANOVA, okay, so now ANOVA madam. Okay, let us see. You have to be very fast, madam. Okay.
Okay, sir.
No, okay is not coming. So you should, okay. If you want to escape, you have to give one another person. Then only you can escape.
Shivakumar sir.
So, okay. Okay. Now, madam,
Sir.
here, what do you see, madam?
Income level, sir.
No, not income level. Total income, one variable. What is the another variable?
Sir.
No, sir, it's not visible.
It's not visible.
Not visible. That you have to tell
Yes,
me.
sir. Yes, sir.
Because I opened a new one, no, so it may not be visible.
Yes, yes, yes. Yes, sir. Yes, sir. Gender, sir. Gender and minutes again.
These are all, let me close, sir.
No, salary and gender. This is okay, sir. Over.
Now what you see, madam? Now, is it visible, madam?
Yes, sir. It is visible.
Yes, sir. Total income and totals.
Total, tell variable name, madam.
Total income, total monthly saving.
Okay, based first you have to look at the label, madam. Total income and the total monthly saving, right? Yeah. Now, what type of variable?
Open the values, sir. Then end with.
Go to values. Now here.
That is my category.
Category variable with
5 category.
Very good, madam. Very good. Super. Okay, now this one.
Metric.
Very good, madam. Super, madam. வர்றீங்க ஃபார்ம்ல பாத்துறலாம். Okay.
Sir, what is that in English, sir? What is that in English?
It is a metric variable 13,000 by 3,000. Each different.
No, sir. Last word, the Palik. What is that, sir?
Which one, madam?
In Tamil, what you told, no, sir. What is that Palik? What in English, sir?
Yeah, no,
last word, last sentence.
I don't
last
remember,
sentence
sir.
told in Tamil.
I said madam is super, madam. Okay.
Oh my God.
Oh, so.
Okay, so now, madam.
Yes.
Okay, now we have one variable category with 5 category. Yes or no?
Yes, sir.
Another variable, metric variable. Fine.
Yes,
Now,
sir.
analyze. Right. Here also compare means, because now how many mean will we have? We have 5 category. Yes or no, madam?
Yes, sir.
Then we will have 5 mean. Yes or no? For each category there will be a mean. Yes, or no? We are going to compare 5 means. 5 means. Very good. Okay. Very good. Right. So analyze. Compare means.
Means. After that, one way ANOVA.
Very good. One way ANOVA. Very good. Now.
Test for test now, sir. No, that is not test.
Yeah.
Dependent list.
Which one I have to put first?
Dependent list.
I have told you no first what variable we have to put.
Metric.
First savings, right? So metric variable we have to put first. That you should not forget. This is very important, madam.
Okay.
Right?
Okay,
Otherwise, what it will do is it will find out mean for the top variable. Right? If you put wrong variable, it will find out mean for that variable. Right? So that is very, very important. Right? Here it is a factor variable. Here it is called what variable, madam?
Factor variable.
So we will not call it as category variable. We call it as factor variable. Right? Here in an independent sample tester, we call it as grouping variable. Here we call it as a factor variable. Right?
Sir.
Very good. Now let me say okay. I'm not touching anything. Let me say okay. Right? Very good. So now you have to think what is the null hypothesis, all this thing. You should keep it in a mind. Right. Okay. So, okay. Now, what is the null hypothesis, madam? Before I could tell, you please tell null hypothesis.
Null hypothesis.
There is
Null hypothesis.
no,
Okay. No difference, sir. No difference.
no difference.
Between
No, no. Between is a wrong word.
No difference.
No difference.
No difference. No difference among.
Among. Very good, madam. Engage with you, madam.
Yes,
Is it, madam, super. Because why we have to use among? Because we have 5 category,
Five
madam.
categories.
Now we have to use the word among. There is no difference among different income category people with respect to their savings. Clear? We are comparing 5 income category people on what? On savings. Yes or no, madam?
Yes, sir.
Okay, now let me tell again. We have 5 income category people, right? Then we will get to the average saving of each income category people, right? We are going to compare 5 category.
Sir,
5
output is
category
not
people.
visible. Output is not visible.
Output not put, madam.
Okay, sir. Okay. Okay, sir.
Still, I'm not giving okay.
Okay, sir.
Okay, so now I'm telling the null hypothesis.
Okay, sir.
Okay. There is no, madam, சொல்லுங்க நீங்க சொல்லிட்டீங்கன்னா நான் போயிருவேன் இல்லன்னா I will explain.
There is no
You tell.
difference among different income category people
With respect to
with
The
respect
saving.
to in
saving.
savings.
with respect to their savings. With respect to their savings.
Savings.
Very good. We are comparing the savings, right? Comparing the means, right? So now we have a result.
Okay.
Can you see something? What you see?
Significant.
see?
Yeah. ANOVA.
Here, what we have to see? Significant value. Yes or no?
Yes,
Significant
sir.
value. Significant value is
Less
When
than.
is less than 0.05.
0.00, which is less than 0.05. Then we have to
Reject.
reject
null
null
hypothesis.
hypothesis, right? Null hypothesis is what? There is no difference among
No
different
difference among different
people
income category people with respect
with
to
respect to their savings. That is rejected.
Yes,
which
rejected.
means there is a difference.
There is the
Clear?
alternative. Yes, sir. Yes, sir.
There is a difference. Now, we say there is a difference.
Yes,
We
sir.
say there is a difference, right?
Yes, sir.
When we say there is a difference,
How much difference is there?
we have to see who is more, who is less, how much difference, all we have to see. Yes or no?
sir.
Yes. So
Yeah.
now that is not available here.
Yes.
That is not available here.
Go
So which
for
means we have to explore. We have to explore, right? Now I am going to explore. Analyze. Compare means.
Sir,
Compare
sir, compare me.
அதெல்லாம் போட்டாச்சு. Compare means all it is there. Now I have to go to post hoc. I have to go to
Post hoc.
Post hoc test. This is the post hoc test. Now in the post hoc test, I am going to use Duncan. D-U-N-C-A-N. D-U-N-C-A-N. Duncan.
Duncan.
Okay, there is a movie, no Duncan movie. That movie, right? Amit Khan. That's right, Duncan. Duncan, right? Now let me see. Okay. Now I can see.
How much
See,
difference?
apart from this table, right? We have seen this is the difference, right?
Yes.
So we said there is a difference among different income category people. Now, since we have clicked the post hoc, I am getting this table. This is a post hoc table. This is a post hoc table. Now look at this post hoc table. Look at the post-hoc table. Look at the post-hoc table. Right. Right. Now, right. You should remember what we have done. Then only we can understand. Right. So we had 5 income category people. Right. 5 income category people. Right.
Yes, sir.
Up 20,000, 20 to 30, 30 to 40, 40 to 50, 50 and above, right? Now n is a number frequency, which means up to 20,000 category, there are 122 people frequency, category variable frequency, income is a category variable frequency, right? Now saving is a metric variable, right? Now,
Yes,
now here we have some values, 5,310. What is this 5,310?
Mean value of this person, sir.
What is this 5,310? 7,000, 10,000, 11,000, all what?
Average income.
Average, not income, average saving.
Oh, sorry, average saving.
Very good. Average saving. Very good. So this income category people, 124 people are there. Yes or no?
Yes, sir.
So this is the average savings of these 124 people belong to this category. This is 70,000. 7,000 is the average saving of this category people. 10,000, this is the average saving of this one. 11,000, this one. 30,000. Now can you see the difference or not?
Yes,
5,000. Huh? There is a difference?
Yes, sir.
Yeah, that is what it has reported. Significant value less than 0.05, which means null hypothesis rejected, which means there is a difference. Right.
Yes.
So now I will let me tell one more easy way, madam. Right.
Okay, sir.
In the chi-square, when the significant value is less than 0.05, there is an association. Yes or no?
Yes, sir.
Yes, sir.
Hello. When
Yes,
it is
sir.
less than 0.05, an association. Yes or no?
Yes, sir. Yes, sir.
Now here when it is less than 0.05, there is a difference. Simple. Why null hypothesis rejected? No difference is rejected. Okay, which means there is a difference. Why 2 steps unnecessarily useless?
Okay.
Yes or no, madam?
Okay, sir.
Now when the significant value is less than 0.05, which means
There is an alternative.
there is an alternative.
Means null rejected.
Null rejected. Null hypothesis is rejected. Alternative hypothesis will be there.
Okay.
Accepted.
No, madam, I am telling a simple method. When it is less than 0.05,
Sir.
here there is a difference. Simple.
Okay, sir.
Tell madam, when it is less than 0.05,
When there is a less than 0.05, there is a difference.
அவ்வளவுதான் madam. That's all. With this also you can follow everywhere. But that method is a right method. Less than 0.05 means reject the null hypothesis. Right? That is the best method. But why unnecessarily simple? Right? High square. Let me tell high square. When it is less than 0.05, there is an association. In a ANOVA, when it is less than 0.05, there is a difference. In a correlation, when it is less than 0.05, there is a relation. In regression, when it is less than 0.05, there is an influence. Simple. Right. That we will come later. Right. So now we have seen there is a difference. So now we have seen the difference. Yes or no, madam?
Yes, sir.
Hello? Yeah.
Sir, I am here.
Now the one matter is over, right? Okay. now I have to tell something more also. Okay, I will come one by one. Right. Let me perform one more. Right. Madam, I am going to perform one more. You have to tell me, madam, one by one, right? I am going to take employee data.
Okay.
I'm going to take employee data, right? So where I'm going to take job category, which is having 3 category variable, and I'm going to take salary.
Not able to see, sir.
Okay. Now not able to see. Yeah, sorry. Okay. I will do. No, okay. I will do. Whenever I am opening new window, I have to share.
Output.
I will come back.
Sir.
Employee data. Employee
No,
data.
income
Now,
level 1.
okay, no, madam. I'm going to take job category and salary, madam. Right? Okay.
No, sir.
So all of
No,
it is,
sir. It is income level 1 file.
okay. Still not visible.
Yes, sir.
Not visible.
So is it okay now?
Output only.
Okay. Employee details.
Yes, sir. Employee
very good.
data.
Okay. Now I'm going to do the. I'm going to take. Okay. So let me. Okay. So now let me take. Let me delete. Okay. Clear. Let me clear. Okay. So that we can easily see, right? So I have one category variable, right, with the 3 categories. Okay, so job category, okay, clerical custodial manager, clerical custodial manager. Another
Okay.
is a current salary, right? Another which is a metric variable, none is there. So you can see metric variable, right? So now I'm going to perform analyze. Madam சொல்லுங்க, analyze.
Analyze, compare me.
Means
One way,
ANOVA. So category variable is a salary. A metric variable is a salary.
Metric variable, salary.
Then I have to put it here.
Yep.
Then category variable is job category having
Factor.
category. I have to put it here, right? Or let me say okay.
Okay.
Now let me go and see the output, right? So now, okay. Now output is right. The significant value. Can you see the output, madam?
Yes, sir. I can see. Sir.
Significant value is
less than 0.05. There is a difference.
Simple. There is a difference. Simple. Unnecessarily many steps. There is a difference, right? Okay. There is a difference, right? So which means some people are getting more salary, some people are getting less salary. We will see. Then okay, I want to see that, right? Now, okay, analyze. Madam, tell analyze.
Analyze, compare.
Compare means
one way ANOVA.
One way ANOVA. Salary here. Okay, here what I have to click?
Post hoc.
Post hoc.
Post hoc.
Okay. Here what I have to click?
Duncan.
Very good. Duncan. Continue. Okay. Now there is difference we have seen, right? Now, okay, there, okay, I'm not given, okay, okay, now, can you see the something?
Yes, sir. Little bit drag it, sir. Little bit drag. Drag, sir. Screen. Drag.
Now,
okay, sir.
Clerical 27,000, custodial 30,000, but manager salary is how much?
63,977.
Okay, which means there is a difference. Okay, but here these two people are in the same group, which means there is no difference between clerical and custodial. But manager, there is a difference, right? So now here also we can see in the earlier test when we have put income category. Now you can see here, right? Income category you can see here, right?
That is third one.
Third one and fourth one, 10,000 and 11,000, right? There is no difference. Yes or no?
Yes, sir.
Okay. So now, see, we have used Tangan. But some people, they will be using the another test, right? So we might require another 20 minutes. We will see, right? Few things let me tell. All right. See, some people, they will be using the other test like, okay, analyze. Okay, let me put slowly. Compare means. Okay, so, okay, sorry. I'm into this already. Income level, right? Okay. Analyze, compare means. One way ANOVA. Savings here, income here, post hoc, Tangan. Okay, you might have seen Tangan, how it has reported. So I am comfortable with the Tangan. Why I am comfortable with the Tangan? So let me have Tangan also. Okay, so let me use one more also, right? Use Tuki. Okay, Tuki. Okay, so Tuki. Can you see Tuki, madam?
Yes, sir, right.
So I clicked 2. Okay, you can click in many things. One for me also, people use LST also, they will use. There are many things, but I'm using these 2 now. Already we have seen Tangan. Okay, so now we will see both. We will see both how it is giving. Right. Okay. So now, so here,
it's showing separately. The key. Income for both.
so
For the first example.
see what I will do is, okay, I will put only one. Then it is doing multiple comparison. Like Tangan we have seen, we'll use Taki only.
Okay.
So what the Taki will do is, okay, this is a Taki test. Okay, you can see it will take first group. It is taking first group.
Okay.
Comparing with the second group.
Okay.
Right. So first group, we know the mean is 5,300. Second group is 7,000. Right. So there is a difference of 1,700. There is a 0.019 less than 0.05, which means there is a difference, which means up to 20,000 people and 20,000 to 30,000 people, they are different. Right? They are different. These 2 people group are different. Now the first group and the third group, 5,000, this is 10,000. So 5,300, 10,000, there is a difference of 4,000. Definitely there is a difference, less than 0.05. Right. So it is taking one group, comparing with another group. Right. It is trying to find out whether there is a difference. So when there is a difference between 2 groups, see, you are taking 5 groups. When there is a difference between 2 groups, then it will say there is a difference. There is no necessity to have the difference among all, no necessity. When you take 5, even when there is a difference between 2, it will say there is a difference. Right. So now here, this is more interesting. 20,000 it is taking, comparing with the 20,000, 30,000, there is a difference. 20,000, 30,000, 40,000, there is a mean difference also is reporting. If you know the mean value, you can 5,000, 7,300, 5,300, 7,000, right? We know, all right, we have seen, and 11,000 and 13,000, right? So 5,300 in saving of these people, this is 7,000, 1,700, there is a difference, significant value. So 5,300, this is 10,000. There is a difference of 4,300, significant difference. Here is a significant difference. Here is a difference. Now let us look at the third group and the fourth group. Now let us look at the third group and fourth group. Third group is 30,000 to 40,000. And the fourth group is 40,000 to 50,000, 10,000, 11,000. There is a difference of 1,100, but the significant value is 0.636, which means there is no difference. That is what we have noted in Tangan also. Right. In a Tangan, we have noticed there is no difference between third group and fourth group. Right. See here, there is no difference between third group and fourth group. 10,000, 11,000. Right. Same result you will get. But I prefer, okay, so Tangan, because there are 5 category people. Right. There are 5 category people. I can divide into how many distinctive category. It shows there are 4 different categories are there. So there is no difference between these two. Okay. So that is why same group, but there are 4 distinctive category people are there with respect to savings that I can find out. But here that information I will not get. That is why I don't prefer this one. Apart from that, it is a very big table. Okay, so that is why I don't prefer. Okay, so that is number. Okay, so now this is with respect to the ANOVA. Right? Now ANOVA is over, but okay, but wait for a few more minutes. For important thing I am going to tell. Many people will not tell, but that is very important also, I feel. See, for every test, there are some assumptions. For example, in a chi-square test, we have seen that, okay, so expected value should not be less than 5. Okay, so that is the assumption we have. Then, okay, so here, the assumption is the group should be homogeneous. The group should be homogeneous. What is this homogeneous? Homogeneity in variance. Homogeneity in variance. We are trying to find out mean difference. But the variance. See, for example, when we compare the eating behavior of male and female, we can compare. Why? Because one male, right, today, for example, Shivakumar sir, right, he will take 4 idli. Some other time he will take 5 idli or 3 idli. Okay, so that madam, okay, so she will take 2 idli or 3 idli like that. The variance, the standard deviation, right, will be same, right? So, right. See, for example, when you compare the eating behavior of human being with camel, what will happen? Camel, one day it will take 1 liter of water, another day it will take 20 liter water. So that is a huge difference will be there in their eating behavior. But when eating behavior, there will not be much difference, which means these two groups are not homogeneous, heterogeneous. The variance is not same. Okay, then it is called heterogeneous, heteroscedasticity, right? So when the variance is same, then only we can compare the means, right? So now the basic assumption of ANOVA is the variance should be same. Otherwise, the group should be homogeneous. The group should be homogeneous, right? So whenever we perform ANOVA, we should check whether they are homogeneous or not, right? So now let me going to check. Okay, so how I am going to check? Analyze, compare means, one way ANOVA, right? One way ANOVA. So savings top, metric variable top, category variable down, options. Okay, this homogeneity. Okay, Continue. Okay. So now this is the homogeneity variable, right? So now I will tell the null hypothesis. The null hypothesis is we want, okay, we want the group should be homogeneous. So null hypothesis is the groups are homogeneous. Otherwise, let me use not, right? Let me use because all null hypothesis we said not, right? Here also you, right? There is no difference in the variance, right? When there is no difference in the variance, which means same, which means homogeneous, right? So null hypothesis is we can say they are homogeneous, right? Otherwise, we can say there is no difference in the variance. Hello, madam.
Yes, sir.
Okay, tell these two sentences. We can say the groups are homogeneous, or otherwise we can tell the variance. There is no difference in the variance, right? There is no difference in the variance. When there is no difference in the variance, right, which means there is no difference, right? Which means same, which means homogeneous. Clear or not clear, madam?
Clear, sir.
Okay. So we want, right? We want groups should be homogeneous. Otherwise, there is no variance, right? Equal variance should be there. So we should accept the null hypothesis because we want groups should be homogeneous, right? There should not be any variance, right? No variance. So we should accept the null hypothesis. When we will accept the null hypothesis? Only when the significant value is greater than 0.05. Yes or no, madam?
Yes, sir.
Okay. So now here my significant value is
Less than
0.05, which means null hypothesis rejected, which means
There
no
is
difference in
no
the variance is rejected, which means there is a difference in the variance, which means we should not perform ANOVA. We should not perform ANOVA. Oh. Then what to do, sir?
What to do, sir?
What to do, sir? Now, then see, whenever you want to ignore the assumption, generally, whenever we want to ignore the assumption, we should go for robust test. We should go for robust anywhere, right? What is robust? It is robust. It will take care of the assumption. That is the meaning. You need not worry about the assumption. That is the meaning, right? So let me go for robust test. Analyze, compare means, one way ANOVA, options. You please write down option. Here, Bell's test. Madam, என்ன test சொல்லுங்க? Bell's test. Right. Let me perform Bell's test. When the assumption is not meeting, right? Otherwise, the homogeneity, when the significant value is less than 0.05, which means no homogeneous, which means heterogeneous, then we should go for Bell's test. Not homogeneous, right? Bell's test, right? Now let us see. Right. Okay. Now, can you see the Wells test set? It is a robust test. What test?
Robust test.
Robust test of equality of mean. Wells test. Can you see Wells test?
Yes, sir.
Yes or no?
Yes, sir.
Okay. So now Wells test, what is the significant value?
0.000.
0.00, right?
Yes, sir.
Which means there is a difference.
Difference.
Yes or no?
Yes, sir.
So Wells test, robust test also telling there is a difference. Clear?
Yes, sir.
Right. Very good. So now, okay. Now let me perform again. Okay. Then only you will understand. Otherwise, I will do little later, right? Okay. So when now there is a difference now, but the groups are heterogeneous. Yes or no, madam? Groups
Yes,
are
sir.
heterogeneous. Am I right?
Sir.
Yeah. But there is a difference. Then I need to perform post-hoc. Now let us see. Analyze. Compare means one way another. Absence. Right. Homogeneity. Let me review. Bell's test. Post-hoc. Now, see, you have not noted down, right? Let me take. Now, read this, madam. Equal variance assumed. Yes or no, madam?
Yes, sir.
What is this one?
Equal variance not assumed.
Okay, which means variance is not same.
Huh.
Yes or no? Equal,
Yes, sir.
which means heterogeneous. Yes or no?
Yes, sir.
Equal, not equal variance. What do you mean by equal, not equal variance? Okay, different variance, right?
Yes, sir.
Okay,
Yes,
so there is a difference in the variance, right? Now, when the homogeneity is failed, then in the post-hoc, you should not use this one. That is why they have given all. Equal variance assumed also given. Equal variance not assumed also given. Can you see? Yes or no?
Yes, sir. Yes, sir.
Now we will use a Turner test. Turner test. Let us say, okay, now, so now there is a difference. Now we will get Turner test. Turner test is similar to, okay, Tuckey test. Now it is taking 20,000, comparing with there is a difference. There is a difference. But here, okay, so as we have noticed, third group and the fourth group, third group and fourth group, right? 30,000 to 40,000, 40,000 to 50,000. So here there is no difference, right? So 9 to 4. So earlier we have seen 0.63. Now here we see the values are little changed. But okay, so we are getting the same result, right? So now there will not be much difference, right? Now, see, for example, I've seen many Viva. Some old people, they will say, by sitting in Viva, they will say, "Hey, those two people are different people. How can you compare? You might have compared some people." They will say, "Hey, those people are different. These people are different. How can you compare?" They will say. Now, hey, don't tell whether they are different or not. Yeah, I've checked. That is what their variance they are telling. Hey, I have checked the variance. Like I could find there is no homogeneity. There is a homogeneity. So I have performed ANOVA, right? But no RIA. If you find that there is a heterogeneity, as you say, they are different groups. Fine, I have accepted because I checked the Levin's test. Levin's test, that is the okay. So homogeneity test, Levin's test. You should see there is a heterogeneity. I've used robust test here. Hey, I've used robust test. Hey. In the post-hoc also, I used Turner test. Hey. Clear or not?
Clear, sir.
Right. So everything is available here. Now, let me perform one by one again. Then, okay. So how to do, I will tell. Right. First of all, let me take the data set. Right. income level. This is a category variable. This is a metric variable, right? First, I have to perform the. First, I have to check for the assumption. That is most important. First, we should check for assumption. Options. We check for homogeneity. This is the first step you should do, right? So now, first step, homogeneity. Okay. Now, let me check the homogeneity test, which is otherwise called Levin's test. Null hypothesis is, okay, the groups are homogeneous. Otherwise, right, normally, right, we will look at the no. Normally, we will use no for null hypothesis. Here, we are checking the variance, right? So, we have to put, right, there is no variance in the variance. Otherwise, there is no difference in the variance. What do you mean by there is no difference? No difference, equal or homogeneous. Both are same. Both are same, right? So, here, to perform ANOVA, we should accept the null hypothesis because our group should be homogeneous. Otherwise, the variance should be equal. Then only you have to perform ANOVA. Otherwise, the significant value should be greater than 0.05. Then only we will accept the null hypothesis, right? If it is greater than 0.05, then perform ANOVA. If it is not greater than 0.05, if it is less than 0.05, go to analyze. Compare means. ANOVA. Here in the option, you perform Bell's test, right? Bell's test, right? Now let us say okay. Let us say okay. Now Bell's test is coming, right? Bell's test. This is the Bell's test, robust test. Now here, okay, this is like ANOVA, right? Comparing the mean, right? So there is no difference in the mean. Now null hypothesis rejected. There is a difference in the mean. When there is a difference in the mean, you should not stop. We should go for a post check-up. Now, since we have used robust test, or there is a heterogeneity, or there is no, okay, there is a, okay, there is no equal variance. There is no equal variance. So, analyze, compare means, okay, ANOVA, right? One way ANOVA, okay, in the post hoc, right? In the post hoc, all right, we have to use equal variance not assumed, equal variance not there. Okay, groups are different, heterogeneity. Then use standard test, right? Continue, okay, which is similar to standard or Tukey test, right? Over, right? Okay. So now, if you have any question, you can ask me. That's all. Madam?
Any questions, please raise your hand so that we allow you to unmute.
Okay, Hallmark Business School, raise to the hand first.
Yes, sir. Please, sir.
Senthil.
Yes.
Senthil.
Yes, sir. Good evening, sir. And good evening, everybody. Yes, sir. Sir, I have two doubts, sir. One is about this. In ANOVA, you said there is an example about human being eating and animals eating, sir. That is heterogeneity. Right? Am I right, sir?
Yes, sir.
Okay. So in that, when we check through this Dunton test, how can we justify that heterogeneity is there, sir? Like even heterogeneity, we said heterogeneity is there, but how can we interpret in that aspect, sir?
No, you are not properly understood, sir. Right.
Sir.
See, first, check the homogeneity, sir.
Yes, sir. Right.
In the homogeneity, right, if it is less than 0.05, they are heterogeneous, matter over.
Okay, sir. No. Sir, my question is,
That's all,
you
sir.
said
No.
that's all.
Your question is wrong, sir. That's all. Matter over, sir. That's
Okay,
all, sir.
okay.
That's all.
Right.
They are heterogeneous. There is a variant. That's all.
Okay.
Lokeshwari, ma'am.
Right.
Don't get confused, sir.
Yes, sir.
Right, sir. Right.
That is proved. We are proving that, sir.
Okay.
It is proving, right? Right. We are not just telling. See, for example, sir, we are comparing the male and female, right? We can compare in the eating behavior, no problem. But in the cosmetic behavior, we cannot compare male and female. Why? Because, right, in cosmetic male, right, I might use a powder, some people may not use powder. The difference is minimal. But when you take female, what will do? Some people, not even they will use powder. Some people, they will use powder, lipstick, and hair dye. Many things they will use. So there will be a heterogeneity. There will be a huge variance, right? So now, see, these are all example we are telling. We need not worry about example. We go with the data, we go with the result, right? Yes or no? We let us data speak, sir. Why you cannot speak on your own? Data should speak. Look at the data. What result it is giving? Interpret that. That's all matter over. When,
Lokeshwari, ma'am.
when homogeneity says,
Yes, sir.
homogeneity says
Wait.
there is less
Hello,
than
sir?
0.5. That is a
Wait,
heterogeneity.
ma'am.
That's a matter over.
Oh, okay, ma'am. Lokeshwari, ma'am. Next.
Yes, sir. I have a very simple question. It's about scales. Actually, that salary value, we are taking it as such in our examples, sir. So we go for this metric level of analysis. If we take it as an interval scale, like we are giving the value like if it is 1 between up to 20,000, if we are choosing it like that, then what can we do, sir? How can we go ahead with this?
No. When the salary is given with 10,000 to 20,000, 20,000 to 40,000 like that, right?
Yes, sir.
Then you have to give me answer, madam.
We use chi-square test.
Answer.
Scale, no.
No. You have to give answer. When you give like that, what is the type of variable?
Categorical.
Category type variable.
Okay, category means when you compare with the category variable, you should use chi-square. Why do you come here?
Yes, sir. That's what I wanted to confirm, sir. That's why I asked.
Yes,
Okay,
yes.
sir.
Right.
Suppose on Likert scale also, right? If it is from
Yes, sir. Yes,
so
madam.
Likert scale.
Yes. Yeah, tell me, madam. Likert scale is a what? Madam, wait. Likert scale is a what type of variable?
It's a ratio table.
Okay, Likert scale, what type of variable?
Metric.
No, Likert scale, what type? Among the four. Interval, right? Interval is a metric, right?
Again, yes, sir.
Interval is a metric, right?
No, category, sir.
Ayya, madam. See,
Metric, sir.
if you
Interval metric.
confuse, madam, please.
Yes, sir.
Madam, please
Yes,
understand.
sir.
If you are not understanding the first class, right, you cannot understand anything, madam, right?
Yes,
So
sir. Yes, sir.
please, that's why I've taken, see, for everything I'm taking this sufficient time, right?
Yes, sir.
So
Yes, sir.
I said 5-point scale is a interval scale, which is a metric variable.
Metric scale. Yes, sir.
Right?
It's a metric variable.
It's a metric variable. It is a metric variable. You can use ANOVA, no condition.
Yes,
Why there is
sir.
a
Okay, sir. Okay, sir.
condition?
Okay, sir. Thank you, sir. Clear, sir. Fully clear. Yes, sir.
No necessary condition, madam.
Yes, sir.
See, no one. See, everything I'm telling based on the literature, right? I'm demonstrating also, right? See,
Yes, sir.
here the income category people are not homogeneous, right? Some people really, okay, high income people, right? High income people, see, some high income people, they save more. Some high income people, they will eat, they will not save. So the variance will be huge. That is what it is reporting. So
Okay, sir.
let us look at the data and let it speak. Right. If you understand the
sir.
variable carefully, then you can write your interpretation very, very nicely. Right.
Okay, sir. Okay, sir.
Thank you, madam.
Sir. Thank you, sir. Thank you so much, sir.
Nandini, ma'am. Nandini ma'am.
Any other question? Three.
Sir,
Who
yes.
I am
participant
here, I
raised?
am here, sir, I am here.
One more question. Only one more.
Sumita.
Who, madam?
Sumita P.
Sir,
Sumita. Yes.
Sumita. Sumita. Yes, madam. Yeah.
Sir, suppose we have
Yeah.
two metric variables, sir,
Hmm.
and one categorical variable with more than two categories, sir. Can we use one way ANOVA again?
Pakka. No problem. See, for example, madam, see here. Okay, ANOVA, compare means, right? See here. See, if we have two metric variable, you can put two metric variable. Yes or no, madam? Hello, madam.
Yes, sir.
Madam, you can put two metric variable, only one category variable. That is the one way ANOVA. Only one category variable. You can use, madam. You can. In fact, we have used independent sample t-test. We have taken two metric variable and one category variable. Yes or no, madam? Saving motives. Nandini madam.
Sir, I am
Nandini
here.
madam.
Sir, I am here, sir. I am here.
Okay. So we have used independent sample t-test. Yes or no, madam?
Yes,
Saving
sir.
motive, family oriented and self-support and gender we have used. Right, madam?
Yes, sir. We use,
So
sir.
like that, two metric variable you can use, but only
One category.
Pakka. That is why it is called
That is for
one way
independent
ANOVA. Pakka.
Thank you, sir. Got it, sir.
Got it.
Nandini ma'am.
Sir, I am here, sir.
Time up.
Okay. Okay. Sir, okay.
Sir, what is the tomorrow timing, sir? Same 6 o'clock, no, sir?
6 o'clock. Tomorrow 6 o'clock. Working day now, sir. Tomorrow 6 o'clock.
Okay.
Okay. Nandini ma'am, conclude.
Yes, sir. Yes, sir. Firstly, I would like to thank our resource person, Karunakar, sorry.
Pranab
Sir-
Mukerjee.
No. The Karunakar Reddy sir and Jairam sir, as well as SCT first, I would like to thank them. Why? Because for giving us such an opportunity by providing a excellent resource person, that is Dr. Kasilingam sir. Kasilingam sir, in today's Days Fdp, we learned about independent sample t-test, and when we used to take that independent sample t-test as well as ANOVA with a very good example. Thank you so much, sir, for your wonderful information with very good explanation for making us very easily understand each and every concept. Thank you, sir. Kasilingam sir.
Okay. Thank you, madam. Thank you. Tomorrow.
I also
Kasilingam, sir. Kasilingam, sir.
Yes, sir.
Nandini madam is asking to attend offline class. Sir. If any update is there, please inform me, sir.
Please inform, sir. Within
Okay.
Bangalore, sir. Within Bangalore. Okay. So I also thank our research cell coordinator, Shivkumar sir. And
Thank you,
all
ma'am.
dear participants for their active participants. Thank you, one and all.
Thank you.
Thank you, sir.
Recording stopped.